Hello and welcome to the second part of the review. This is question 38. The box plot below shows salaries for construction workers and teachers. If a person is making the minimum salary for a construction worker, they are making more than what percentage of teachers? So this is the person who makes a minimum construction worker salary, that is $30,000 per year. We notice that a quarter of the teachers make less than $30,000 per year. So that is exactly 25%. This construction worker makes more than 25% of the teachers. The next question is about the empirical rule. So when we talk about the empirical rule, the first thing that you will need to do is to create the normal distribution and put the numbers of the normal distribution, and then you can easily find the answer to the questions. So let me just clip this and put it into Excel, and I will show you how to answer that question. So the question is asking us to find percentages between certain numbers and less than and etc. The graph illustrates the distribution of test scores taken by college algebra students. The maximum possible scores on the test was 130, while the mean of the score was 76, and the standard deviation was 12. So those are the two important numbers. We're going to create the normal distribution, so I'm going to transfer this shape into here. And I know that the mean is going to go in the middle, 76. And then I'm going to find three numbers to the right and three numbers to the left, just because the empirical rule just tells us about the percentages within 3 standard deviations of the mean. That's the reason we need three numbers. So if you add 1 standard deviation here, you're going to get 88, as you can see here. This is this number. And then if you add another standard deviation, you're going to get 100. And then one more standard deviation gives you 112. If you subtract 1 standard deviation, you get 64. If you subtract one more standard deviation, you're going to get 52. When you subtract one more standard deviation, you get 40. So this is what we have here. So following the empirical rule, we know that 68% is within 1 standard deviation of the mean. If you split it in half, that's going to give us 43, 34% here and 34% there. And then we know that 95% of the data lies within 2 standard deviations of the mean. So between 52 and 100, that is 95% of the data. So this part is 13.5%, and this part is 13.5%. If you add all of these together, they're going to give you 95%. And then within 3 standard deviations of the mean, between 40 and 112, we will have 99.7% of the data. That leaves us with 2.35 here and 2.35 here. That means if we add all of these up there, we're going to get 99.7%. And then the rest of the data is going to be 100% minus 99.7 divided by 2. That will give us 0.15 in the tail and 0.15% in the tail. All of these are percentages. Now that we have all of these numbers, we're halfway through answering that question. This is actually the main idea of the question. So what is the approximate percentage of students who score between 64 and 88? So 64 is right here. Let me change this to a lighter color. 64 is here, so I'm going to highlight the line. And 88 is this number, so I'm going to highlight the line here. So if I add anything in between that, that's going to give me exactly the percentage of students who scored between 64 and 88%, and that is 68%. So this answer right here is going to be 68%. I added 34 and 34, and I got 68%. Now, the next one, what is the approximate percentage of students who scored between 76 and 112? 76 is here, and 112% is right here. So this line with this line. Now, anything in between that is going to answer the second question. So we said the first question's answer was 68%. I'm just going to prove that that's right. And I'm going to say 68. So the first one is right. The second one, I'm just going to add all of these percentages. So this is equal to 34 plus 13.5 plus 2.35. So the answer is 49.85. I'm going to copy that. The next question, what is the percentage of students who scored higher than 100? So higher than 100, this is the 100 mark. So this is the 100 mark. Anything higher than that, that means it's to the right of it. So all of this area. So basically, we're going to add those two numbers in the highlighted area, which is going to give us basically 2.35 plus 0.15, that is going to give us 2.5. So that is 2.5, and then higher than 112. If you look at the graph, you'll see that anything that is higher than 112 is going to be 0.15. So the answer here is 0.15. And just to clarify, I made the typo here. So this number is not actually 115, it's 112, okay? Because that's the number right here. So this is how you're going to answer this question for the empirical rule. The next question, number 40, is basically we want to find the correlation coefficient. So to find the correlation coefficient, we're going to select both the columns and paste that on Excel. So here we go. If that happens to you, that means we need to highlight a little bit more. So we're going to select like the row before that, and then we select the entire table, and then go ahead and paste it into an Excel sheet. So the correlation coefficient can be computed in two methods. One of the methods is the easiest method, which is you say equal to correlation. So correl, and then select the first array, which is the x, the explanatory variable, and then comma, and then select the response variable or the y variable, and then click enter. So I'm going to copy that correlation coefficient. I'm going to copy that and paste it into the answer box. Now we have this question here, and we want to see whether this represents a strong or moderate relation, if it's negative or positive. As you notice, this scatter, first of all, the trend is going downwards, so it's going to be negative. We're not going to go with the positive numbers, so our options are limited to the negative numbers and 0. Next, we see a trend, so it's not 0. Then we look at the strength of this relation. Notice the shape that is linear is very visible. So it's not like those points are all over the place, but the overall trend is downwards. I can see a strong correlation between those numbers or those dots. They are very close and tight together. So that means this is a negative strong correlation. And we're going to choose negative 0.9 because it's very close to 1 and it's not close to 0. So that is how you identify the relation here. In this question, we want to find the regression line or the least square regression line or the regression line. To answer this question, I'm going to copy this data and paste it into an Excel sheet. Now I want to create the least regression line. So to find the least square regression line, I'm going to select both columns together, go to the Insert tab, and then go to the scatter plot and draw the scatter plot. Next, you're gonna go to the plus sign, and then you're gonna go to the trend line, go to more options. On the trend line, you will see a window pop up, and you're going to display the equation, and there is another option where you can display the R square, which is the correlation coefficient squared. Okay. So here is the equation. The equation is negative 1.2597x. So I'm going to put the number here. I do have the x, so I don't have to type that in. I'm going to put the y-intercept, which is the second number. The second number, let me just move it around so I can see it better. So it's 21.755. This is how you're going to compute the least regression line. Notice how I displayed also R square. This method, you have to think about whether it is negative or positive. So in this case, the trend is going downwards. Besides, the slope here is negative. So I know that the correlation is going to be negative also. So I'm going to say this is negative SQRT, the square root of the R square, which is 0.9642. So that is the correlation coefficient using this method. Again, for this method, you will need to think about whether it's negative or positive. So this is not the best method to find the R, the correlation coefficient, but it's a good method to find the regression line. For those who don't have the plus sign, when you click on the graph itself, you will see that you have add chart element here. So you can go ahead and go to the trend line and then go to more trend line options, and this window is going to open for you. Make sure you click on the histogram for the options to appear, so you can display the equation and display r square on your line as well. So whether you have the plus sign or you don't have the plus sign, you still can do that. The next question, we have the regression results. So we ran the regression and we came up with those results. We have A, we have B. A and B can be put in this equation to be the regression line, and we have the correlation coefficient also. We want to predict the number of sit-ups a person who watches 6 hours of TV can do, rounded to 1 decimal place, because this equation basically represents the number of sit-ups a person can do watching TV. So to do that, first we're going to build the equation. We have to determine A and B. We have A and B. So our equation is negative 0.717x plus 27.59. So our equation is negative 0.717. I'm going to write the x right here, plus 27.59. So I'm going to write 27.59 right here. Now I know the equation. I want to predict a value when x is equal to 6 hours. So if the person watches 6 hours, what is the number of sit-ups a person can do? So I'm going to replace x with 6. So to compute that, I'm going to say this is equal to this number times 6 plus this number right here, the y, or the y-intercept. So the answer is 23.288. We're going to round it to 1 decimal. So go to the home tab. This is going to round it for you to 1 decimal. I'm going to copy that. For the next question, we want to compute the correlation coefficient. We want to find the least square regression line, and we want to interpret the slope. First, I'm going to compute the correlation coefficient. So correl, then x, comma, y, enter. I'm going to copy that. I'm going to copy that and paste it over here. We need to round it to 3 decimals, so I should have rounded this to 3 decimals first. So I'm going to go ahead and just remove all of these numbers. Now we want to find the equation, so I'm going to select both columns, go to the insert tab, go to the scatter plot, choose the scatter plot, the plus sign, and then trend line. From the trend line, I'm going to select more options, and then I will click on the histogram and then select to display the equation, because that's what I'm interested in. So the equation is right here, negative 1.2495x. So I type the number here without the x, of course, because it's right here already, plus 96.123. So plus 96.123. So we want to round each to 5 decimal places. I should have done that already. So let me type this number here, negative 1.2495, and I need to round this number to 3 decimals. So I'm just going to click on it and then round it to 3 decimals too. So negative 1.250. We're going to interpret the slope. So here the slope is going to be negative. The interpretation here, we have the variable x and the variable y. We don't know what the variable x represents or the variable y represents, but we know that y depends on x. So for each 1 unit increase in the x value, we expect the y value to decrease by 1.25. So that is how we are going to interpret the y-intercept. So for each unit increase in the x value, the y value to decrease by 1.250 or 25. Decrease because it's negative, and this is the slope basically. So that is the interpretation of the slope. we predict the value on average for the response variable will be obtained from the value of 2.8 as the explanatory variable. So this means if we plug x is equal to 2.8, what do you expect the y to be? So this is similar to the previous process. So we're going to just plug the information here. We're going to say this is equal to, the slope is negative 1.250 times the value that we want to predict, which is 2.8, plus the y-intercept, which is 96.123. 96, it's not 69. Okay, so I just realized that I made an error there. So this is the predicted value, and I made an error here. Let me fix it, 96.123. So this should give us the right answer. Of course, this part usually is graded by hand, so don't worry about this. Even if it gives you the wrong answer, don't worry about it. This is usually left to the end. I will grade these when I have time. The next question is similar, but in this case, we need to predict y-intercept also. We want to comment on the strength and direction of the relation, and we want to interpret the y-intercept, and we want to find a residual as well. So I'm going to take the entire table from here. The Consumer Price Index, CPI, measures the average change over time in the prices paid by urban customers for consumer goods and services. The U.S. Bureau of Labor Statistics keeps track of this data on a month-to-month basis over the years. This table contains the value for the month of December of the listed years. We want the correlation coefficient and see what it means in terms of year and CPI. And then we're going to compute the correlation coefficient here. So this is correl x, comma, y. So this is the correlation coefficient. I'm going to enter it here. And this gives us a hint here to comment about the strength and the relation of the direction of the relation. So we're going to say there is a strong positive correlation between the year and the CPI for December. We want the equation of the regression line. So we're going to select both columns, insert tab, scatter plot, plus sign, trend line, more options, and then histogram, and then select display the equation. So this is basically the equation that we want to compute. So I'm just going to go ahead and plug it there. So I plugged the numbers here. Notice how this number is negative. So I plugged it negative in the equation here. It is negative, and we need to round it to a whole number. So I rounded it already to a whole number. I need to round A to 3 decimals. So I should have rounded this to this number, but we'll take it anyways. So it's not a big deal. We want to interpret the y-intercept. So what does this y-intercept mean? X represents the year. So if I say the year is 0, that is not going to make any sense. So I'm going to say here, there is no interpretation for the y-intercept because the value for x equals 0 doesn't make any sense. Because what is 0? What is year 0, right? We don't have any CPI when the year was 0. It doesn't make any sense in the context, and as a result, we're not going to interpret it. We want to predict the CPI value for December 2021. So 2021 is not too far from the table. We can still use this equation to interpret that. So if we interpret that, we're going to say this is equal to the slope times 2021 minus this value over here, which is going to give us this number. So that is how you do that question. So this is the predicted value for 2021. So we took the number, which is this number right here. That is the slope rounded to 3 decimals times the x value 2021 minus the y-intercept, because it's minus right here in the equation. So minus 8,148. That gave us number. I took this number, pasted over here. That was the answer. The residual. Now, give the residual for December 2019. The observed value for 2019 is 258. So I'm going to put that number here, 258. And then I want to find the predicted value. So to find the predicted value, I'm just going to change the number here from 2020 to 2019. So this is the predicted value. I'm just going to copy it and paste it over here. Should have copied and pasted it as value over here. So here we go. So the residual is the observed value minus the predicted value. That will give me negative 116. So we'll take this number and paste it over here. And that will be the answer. I hope this video helped you prepare for the test. If you have any questions, please let me know.